Alright, so I'm going to be talking about Common Lisp. Before we get into Common Lisp, a little bit should be said about the bigger Lisp family. Here I have a few different dialects of Lisp, but the OG Lisp was created in the late 1950s by this guy here, John McCarthy, and it was thought of as a sort of mathematical notation for computer programs. Interestingly, John McCarthy is the same person who coined the term artificial intelligence. Anyway, it was called Lisp because it was meant to be a list processing language. And that kind of makes sense. The source code for Lisp programs are themselves lists, which can be manipulated by the program as a data structure, and that allows for all kinds of complex macro systems and customizability. And all that customizability gave rise to a lot of domain-specific languages, like these dialects I mentioned earlier, and that's one of the reasons why Lisp and the Lisp language family is so fractured, and perhaps why it never took off like some of the more standardized languages, despite actually introducing a huge number of really innovative features. It did, however, become widely used in the AI community, and Common Lisp was ultimately designed to standardize some of the family here. It took a lot of inspiration from Scheme and Mac Lisp, and it was hoping to also increase portability and accessibility. Just an interesting thing here, I have a picture of a Lisp machine. You can kind of read the title there, and that's a piece of hardware that was specifically designed to run Lisp code. These are not very common anymore, but in the early days of Lisp, that was a thing. So some big ideas that Lisp introduced were conditionals. This was a big deviation from the main programming language at the time, Fortran, which only had a conditional goto. McCarthy included conditionals in Lisp, and he was actually on the Algol creation committee, and he pushed for their inclusion in that. And they were adopted, and that likely had a big impact on the rest of programming languages as we know them now. Functions. In Lisp, functions are first-class objects. It's sort of a functional programming language. We'll touch on that a little bit more later. But they're a data type that can be stored, passed, returned. And this was actually the first implementation of recursion. That makes sense given that this is a pretty functional language. Variables are all basically pointers, so variables don't have types, values have types. And when you bind variables, it's more like copying pointers and not what they're pointing to. Some nuance there. Memory allocation is done automatically with garbage collection, so no more manual memory stuff. Everything is an expression. And that means that all code, even control structures like if or else, then everything returns a value. It has this property called homoiconicity, which means that similar to Prolog, there's kind of a gray area, a fuzziness between code and data. So in Lisp, the code can be interpreted as data, and the data can be interpreted as code, and it's pretty simple, just a few keywords that can make that happen. And that allows for a huge amount of flexibility and kind of adapting the program while it's operating. And that feeds right into the last point, availability. The whole program is basically available all the time. There's not a lot of distinction between read time and compile time and run time. You can kind of interact with the program in any way at any of those times, and for example, running at compile time is sort of the basis for how macros work. So some general details about Common Lisp. I mentioned earlier that it's sort of a functional language, but it's actually more than that. It's a multi-paradigm language. You can program imperatively, you can program functionally, you can even program object-orientedly. That's what this class thing is. That's the Common Lisp object system, which is how you build objects and use them in Common Lisp. It can be compiled or interpreted. It has this thing called REPL, which is the read, eval, print loop, and that's a way to sort of dynamically engage with the program while it's running, so you can make changes to the code while the code is running. It's really cool. It has hot reloading, so that's, you can restart the program and see changes to the program without totally rebooting the whole application. It even has incremental compilation. And it's dynamically typed, but kind of keeping in theme with all this flexibility, you can have optional type declarations. And then similarly, it has lexical scope, but just with these keywords, special and def of R, you can create globally scoped variables if you want. So a little bit about syntax and structure. All of Lisp is composed of what are called S expressions, and these are basically just nested list data. And S expressions themselves are composed of atoms and lists, where atoms are things like numbers, strings, symbols. Symbols are kind of like enums, or they're kind of like in Prolog what are called atoms. It's a little bit confusing. Prolog atoms are they're symbols in Lisp, and atoms are like a bigger super category of that. But anyway, lists are just lists of atoms or lists. It has prefix notation, so you can see here this would be 3 plus 4, the quantity times 2, which is 14. And just for future notice, whenever there's a semicolon in Lisp, that's a comment, so this is just comment that it equals 14. There's also this cool thing with quote and eval. So this is kind of what I mentioned earlier about the homoiconicity, that with the quote here you just do a small single quote before any piece of code. That will prevent evaluation in the program. Or with the keyword eval, you can sort of reverse that. There's also other ways to get around this. It gets kind of complicated, but the main idea is that you can switch in Prolog in Common Lisp between what's code and what's data, what's evaluatable and what's not. A little bit about some examples of Common Lisp control flow. This is a simple conditional. Is 5 less than 10? The then and else are implied, so if 5 is less than 10, execute 5 is less than 10, otherwise execute 5 is not less than 10. This is a different example using a condition control system. And essentially this will use the first one that evaluates correctly, and the rest will be ignored. Here, this is a key and key list control system. This is useful for if you want to check against a specific value. It'll just look for which part of the key list matches with the key. In this case, it's an apple. And some other important things like looping. This is a basic loop. So you just print out 0 through 4, and then here we are iterating over a list, so we're just going to print all the elements in the list. And a little bit about lists, since Prolog is so into them. Prolog again, my goodness, Common Lisp. All lists are actually composed of what are called cons. And these are basically pairs of values that have two parts, the CAR part and the CDR part. The CAR part is the contents of address part of register, and the CDR part is contents of decrement part of register. And this is kind of like a linked list, and so Lisp will be composed of a bunch of lists that are themselves composed of these tiny units of like mini linked lists. So when we actually create a list here, just a simple list instantiation, what we're really doing is creating 3 of these cons, one that has the value 1, and then the CDR is pointing to the value 2, and then that CDR is pointing to the value 3, and then there's a null CDR for the last element. And some basic functions that we can do to lists, we can append them. So here we're appending the 3 and 4 to the 1 and 2 and returning 1, 2, 3, 4. We can do the same thing in different combinations, basically what all this is showing. And to access any element in a list, you can use this nth keyword. This will return the nth element of the list, and you'll notice here it's a 0-based numbering system like most people would be used to. A little bit about functions. This is a simple example of creating a function. So you have this def fun. In this case, it's adding 2 numbers. If you're interested, you can also have anonymous functions with the lambda keyword. And a simple example of recursion, kind of the canonical factorial. Other than the syntax, really nothing abnormal. So some examples of common Lisp in the real world. Some of you may already know this, but Reddit was actually developed initially in Common Lisp, and it was actually developed by UVA computer science students, so that's pretty cool. It did eventually get rewritten in Python, though. Also, Grammarly used to be a big deal before ChatGPT seems to have made them irrelevant, but they use Common Lisp in their core grammar engine too. And even the Hubble Space Telescope was running a scheduling system called Spike, which was written in Common Lisp. So the big takeaways for me were that it's super versatile, super customizable. You can customize the language to suit whatever paradigm you're interested in. And I'm glad I got to look into it and tell you all about it.